All right. Hello, everyone, and welcome to Java Nostalgia and Fun Facts, third year of innovation. My name is Mihaela. I am a software architect at Systematic. This is a Danish company, if you heard of us, which is specialized in building software in what we like to call critical domains, such as defense. We are building software for the military domain, the department for which I'm working, but we also have healthcare, national security risk, and many others. I'm also a teacher at the Faculty of Cybernetics and Informatics in Bucharest in Romania. But today, I'm actually here and I'm thrilled to be celebrating a big milestone because this year we have 30th birthday for Java. It was actually on 23 May, so a couple of days ago. So there are 3 decades of coding and innovation. And in today's session, we are going to explore a little bit of the history, the iconic, some symbols like Duke, like the coffee cup, some evolutions through the versions, and yes, I'm going to test your Java memory with some trivia and fun facts. So you're not just here to watch some slides that I'm going to share, you're actually here to play. And I don't have prizes, but bragging rights are on the line. So please have your phone nearby, because I will shortly share all the details for you to join the quiz. But here's what we've got lined up. So we'll start by warming up with a little quiz to jog those Java memories. Then we'll go back to the roots, meet some old friends like Duke, and run through the key milestones and innovations altogether. We'll also look at some real code examples from the early days versus modern Java. And once again, we'll sprinkle in quizzes and fun facts till the end of the presentation. And with this said, let's get started. I did mention to have your phone prepared, so please scan the QR code. I have tested it before the session, but in case something happened, you also have the possibility of just providing their slido.com in your browser and enter those number details, 3107945. I will also launch the quiz, but don't be concerned if no questions are popping up at the moment. I'll have to manually enable them and discuss about them and stuff like this. So far, please just scan the QR code and join there. And let's dive into the depth of Java history and innovations. And hopefully everyone is ready. I'll wait a few more seconds. I see that we have plenty that you have already joined. It's just a fun quiz to see how much you remember from the early days, or at least what have you read about those time. And why not, maybe we will also learn something new altogether. So, ready for the first question? Let's see. I'll first read it and afterwards I'll trigger it. So, what was the original name that was assigned for the Java? This is the first question. And don't worry, no points lost for wrong answers, just some warm-up bragging rights. So it's time for you to submit your answer. I have enabled it. And among the possibilities, we have oak, maple, pine, elm. Let's see. I think I forgot to answer that just one answer is correct, because I see that all of them are being selected. You can only select one, but one is right. So let's see. So far, A is winning, but B also has some votes. And a few more seconds. And I think time's up. Ready to see what was the correct first name. And those of you that selected option A, you're totally right. Back in the early 90s, when Java was still in its earliest form, it was developed as part of something called Green Project at Sun Microsystem. And the language was originally named after the oak tree that stood outside the windows of James Gosling, one of the Java's father. And this is how it got the name. Right, first question was easy. Let's see the next one. When did Java officially launch? This one's for the timeline detectives among you. I'll enable the possibility of you to submit your answer. So we know that it has been around for decades. You can do the math and see exactly the year. And let's see. Once again, all of the answers are being selected. Let's see till the end. 10 more seconds left. And time is up. And the majority answered correctly. That's when Java was officially launched to the public. Specifically on 23 May, I did mention the date at the beginning of my presentation, in 1995 at Sun World Conference, the name was. It was then when Netscape announced that it would integrate Java into the browser, which really boosted its visibility. But to clarify a bit the dates, because I noticed that the other answers were also corrected, 93 and 97 has nothing to do. I just put some random numbers over there to have 4 answers. But 91 could have been selected because Java's development actually started in 1991 under the Green project that I told you about. But it wasn't until 95 when it was released as a core technology. So this is why the difference. Okay, moving on. We have a few more questions at the beginning, and we will move to something else. And here's one that might split the crowd a bit, especially if you've seen some of the quirky Java-related images online or from past conferences. So, what was the name of Java's official mascot? Let's see what you answer. It was Joe, it was Java Man, it was Bean Boy, or it was Duke? What do you think? Okay, 15 seconds left. You still have time to submit your answer. Although I do think we already have a winner over there. And yeah, almost everyone correctly answered Duke. Duke was created by Joe Parlang, and he later worked on movies like Shrek, like Ice Age, and others. I don't know others, but there were a lot. And he eventually became the Java image or the Java face. I saw that you picked others from there, like Java Man. Well, I admire the superhero naming. Maybe we will have at some point some Threadwoman or some Captain Garbage Collector, who knows, in Java. Let's move to the next question. So, another one, which I think it's a bit tricky. It might surprise even some long-time Java developers in the room. So think way back, before Java was in our IDEs, before it was running enterprise apps or Android. What was it originally created for? And you can now submit your answer. We have to choose between web applications, interactive television, database tools, and mobile phones. Let's see what you think. What do you remember what you have read from that period? What was it originally created for? We don't have a clear winner at some point. We have 2 with 30%, but let's see till the end. A few more seconds left. Okay, time's up. Curious to see the result? And it was B. It was a bit challenging, but interesting, I hope. Java was originally designed in 1991, as mentioned, by the team at Sun Microsystem for interactive television, specifically for set-top boxes. However, the technology was too advanced at that moment for the digital cable industry at the time, so the project pivoted it towards broader platform independence. So that phrase with write once, run anywhere. So Java went to conquer the internet, enterprise, and so on. So it was originally developed for interactive television. All right, and one more. Let's see, another deeper question. What was Duke originally created for? Was he always just the mascot? Maybe it was, maybe it wasn't. Let's see, what do you think? And you can submit the answer. The first one is yes, it was designed just to be a mascot, but we also have a chatbot, a software agent, or error handler. What do you think? Once again, we don't have a majority for one of the answers. We are in between C and D at this moment. Let's see till the end. And time's up. And the right answer was C. It was highly voted, I have to admit, not the first choice for many of you, but it wasn't just a mascot from the start. He was created as a software agent for something called Star 7 project. It was an interactive handler, home entertainment controller, so this was for what it was originally created for. But over time has evolved into the official mascot of Java technology. Okay, I hope you had some fun. This was just the first round. Don't throw away this quiz because we will have some more questions later on. But this time, I would like to look a little bit at the origins because in the early 90s, as mentioned, a visionary team at Sun Microsystems formed by James Gosling, Mike Sheridan, and Patrick Norton, they embarked on the Green Project. Their mission was ambitious at that moment. They wanted to create a programming language that could operate across various consumer electronic devices. They wanted to ensure interoperability, and they wanted to ensure ease of use. And their initiative at that time aimed to lay the groundwork for a future where smart devices could seamlessly interact. So a concept that would revolutionize over time. This was when everything started. Afterwards, to showcase the capabilities of their new language, the one that they were working on, the Green Project team have developed the Star 7 device that was in one of our previous questions that we have seen. And their innovative prototype featured a touchscreen interface and some wireless communications, allowing it to control various home wireless communication devices. And that project, Star 7, wasn't just a technological marvel. It was a tangible representation of the team's vision for interconnected smart devices. Although it never reached commercial production, Star 7 played a crucial role in testing and refining the language that would eventually become Java that we worked with today. Initially, okay, now I was looking that it wasn't loaded. Initially, the team named their language Oak, was we have seen in the first question. It was inspired by the oak tree outside Gosling's office, but they couldn't keep the name because of some trademarks conflicts with the oak technology. So a new name was necessary. And after a brainstorming session, at least from what I have read so far, the team settled on Java. And it was inspired by the coffee from the Java island. And with its guiding philosophy of write once, run anywhere, Java was poised to revolutionize the world of programming. This is how it got its name. All right, so at this moment, we have a name, Java, and we have a bold vision, write once, run anywhere. But what's a great language without the little character that we have seen? So the mascot, the Duke mascot, and the face, and the curious little guy named Duke. And of course, the symbol that every Java developers, all of us know, the coffee cup. So this is how everything started. And in the next couple of minutes, let's talk a little bit more about Duke, which was the iconic triangle-shaped mascot that we all recognize. Duke was originally designed as a software agent, we've seen this, for the Star 7 device, and it was helping us to interact with users in a friendly and intuitive way. Think of him as an early virtual assistant, for example. It was designed by Joe, who later worked on those movies that I mentioned about, like Shrek, Ice Age, and I remember another one, The Prince of Egypt. And its interactive and distinctive style and friendly vibe made him the perfect face for Java. Over time, Duke became Java's official mascot, representing the platform's approachable nature. And here's a fun fact as well, as I mentioned there, it is open source today. So you can even incorporate, if you already haven't done this, into your own Java projects. And let's see a bit now about the coffee part. What is it with it? So the language name Java, as mentioned, was inspired by the coffee beans grown on the Indonesian island of Java. Legend has it that the development team behind Java enjoyed so much coffee that they decided to name the language after it. And that brings us to the iconic coffee cup logo. This logo, it is mentioned that it symbolizes energy, simplicity, and the universal experience of developers all around the world. And unlike other tech logos that undergo constant change, the Java coffee cup stood the test over time, so it remained the same. And before we dive into some Java's technical milestone, let's remember that the language identity, its friendly mascot Duke, and its iconic coffee cup logo helped build a community of passionate developers all over the places, including here in Portugal. And now it's time to move beyond the personality of Java and look at some of the hard-hitting milestones that shaped its legacy. From applets to enterprise systems to functional programming and the new modular architecture, Java history is rich and with exciting innovations. So let's explore how Java has transformed from a very small web tool that it was in the early 90s to the global technology that it is today. So let's take them by years. At least I try to focus on those that I consider the most important ones. So let's walk through the key milestones that have defined Java's 30-year journey. Starting with Java 1.0, which appeared in 1995, Java brought us the revolutionary idea of write once, run anywhere, and this made it possible to run Java code on any platform. Early web applets showed Java's promise for web development in the early days. Afterwards, 3 years later, in 1998, we had Java 2, which introduced the Enterprise Edition platform, which added key technologies like servlets, like AGBs, and this marked the beginning of Java independence. And it started to create a community around the Java 1 conference, which remains a major event in the Java world now of today. Going forward, in 2004, we had Java 5, which was another pivotal moment. It introduced features like generics, like metadata annotations, and the for each loop, for example, which all of these were making Java more modern and developer-friendly, developer-oriented friendly. And this release was also focused on performance improvements, making Java a more robust and more efficient language. 10 years later, we will talk about this 10 years gap. In 2014, Java 8 introduced lambdas and streams, allowing developers to embrace functional programming. So it was also back then when we started to have the date and time API, which solved some of the long-standing issues with date manipulation in Java. I remember that I also started working with Java 5. When I initially started working in the industry, the application I was working on at that time had Java 5. And we had plenty of issues with those date and time part, especially with conversion and calculation methods and so on. So we were very happy when Java 8 appeared and started to fix a lot of those issues, for which we had to manually do a lot of workarounds. So it was a huge improvement at that time. And as mentioned, keep it for a bit later, those 10 years gap difference. Moving forward, I chose 2017 when Java 9 appeared, which marked another significant change with the introduction of Java modules. Because they enable the possibility of modularization for our applications. And this change helped us to build even more scalable, more maintainable systems. And starting with Java 9, we also had a 6 months release cycle, which meant that developers would get new Java features at a much faster rate. And this 6 months release cycle is still up and running today. Since then, we had, for example, Java 16, Java 17, 18, 19. They continued this 6 month release cycle, and with each release we saw new features such as records, we had sealed classes, we had pattern matching, and many significant performance optimizations, new garbage collectors, and a lot of improvements with the existing ones. And the most recent version, Java 24, released just a couple of months ago, continued on this pattern, showing that Java remains an evolving language, showing that it is always looking to meet the needs of us, of our developers and our applications, to be able to make them more modern. And in September we'll have 25, Java 25, which will continue on the same path. All right. I did mention about those 10 years. So between Java 5 in 2004 and Java 8 in 2014, there was a significant 10-year gap that might be surprising, considering how quickly technology evolves. So there was an important context behind this period, because after Java 5, the Java platform largely entered the phase of stabilization. So the Java team focused on stabilizing the current functionalities instead of building on top of the existing ones. While there were new releases, such as Java 6, for example, in 2006, or Java 7, they were more focused on refinements. They were more focused on performance improvements, on security enhancements, rather than just adding new major features. I think that Java's priority during that time was more focused on backwards compatibility, ensuring that our application, or the existing application at that time, would continue to run smoothly without breaking anything. And this is the period when Java entrenched itself deeply in the enterprise world, because technologies like the Java Enterprise Edition were heavily used, and frameworks like Spring started to appear as well. So this is when the Java started to focus more on stabilization. And afterwards, we've all seen that we had quite a lot of releases with quite a lot of functionalities. Moving forward, it's time to explore a bit the milestone and key moments in a more technical perspective. And let's dive now into some of the key innovations that made each Java version undergo some groundbreaking changes. Introducing, by example, generics, lambda expressions, and so on with Java 8, or some of the new stuff, records, seal classes, and so on. So we've seen how Java evolved over the time, and let's take them release by release. So in Java 5, for example, we had in 2004, we had the generics, we had the metadata annotations, we had the for each loop. Continuing, in Java 6, we got the scripting API, which enabled Java to run scripting languages like JavaScript, which brought more flexibility and integration with dynamic languages. For example, in the application that I told you about that we started with Java 5, afterwards with the scripting API, we started to build something called the collaborative editor, which was a, let's say, full stack part of application with a backend on Java and front end on some very old technologies. And we were able to do some manipulations and reduce the algorithms that were supposed to be created for the collaborative part. Like you have 10 users all connected to the same editor at the same time. One of them is making a change. Everything else needs to get to the other one. On the Java side, at least in particular, this scripting API helped us a lot. But let's continue. The real game changer here, I think it was Java 7 with the try with resources, because this one significantly improved the resource management in Java. But obviously, the defining period was in Java 8 with the lambda expressions, because it enabled the functional programming style and provided us with the streams API, which changed how we process collections. And it's still being heavily used in all our applications. Also, the date-time API that we talked earlier was a critical addition, replacing the old mutable date and calendar classes with a very modern and immutable API. Let's look at another group of versions and functionalities. So moving from Java 9 to 16 this time. Java introduced modularization with the module system, so under the project Jigsaw, which reshaped how developers could organize and manage Java applications. Then we have the JShell, that also made it easier to test Java snippets quickly. In Java 10, we have the var keyword that was introduced, simplifying local variable declarations and making or helping to make our code even more concise by using it. Afterwards, in Java 11, so in 2018, the language saw critical additions like HTTP client API, making HTTP requests easier and more flexible. We also had flight recorder that was useful for the performance monitoring. Then in Java 12, we had the Shenandoah garbage collector, which was or is a low latency garbage collector. We also had at that moment a preview for the switch expressions, which later became a full feature in Java 14, so in 2020. Besides that, in Java 14, we had records that were introduced, which simplified immutable data structures. Also, Java 15 brought sealed classes, offering a more controlled inheritance control, as well as the production of the Z garbage collector. It appeared at the same time as well. And now looking at the last group of features, so from 17 to 24, the latest one, appeared at least, because we'll have in September 2025, sorry. Java 17, well, this was a long-term support version. It released a pattern matching for switch. This is when they become fully available, marking complex conditional logic and simplified how we work with this. The sealed classes and sealed interfaces also became more widely used to give developers better control over inheritance and class hierarchies. Then we had Java 18, which introduced the vector API in an incubator state, but it enabled a more efficient handling of data operations on vectors. And also a simple web server was added for testing and prototype in Java 18. Afterwards, recent version, in Java 19, we had the preview of the virtual threads under the project Loom, which marked a shift in how Java handles concurrency, making it easier to manage large number of lightweight threads. And also the foreign function and memory API appeared, at least in an incubated state, in that version. Afterwards, Java 20, which appeared 2 years ago, continued this focus with structure concurrency because it improved the thread management process, but also expanded the support for virtual threads. Java 21 also saw recurse pattern and continued the evolution of Project Loom, making it even easier to work with in the concurrency world. And finally, last one here on my list, Java 24, which brought further refinements to Project Loom, and also expanding on the Project Panama, because it allowed Java to interact even more efficiently with the native code, which opens up more possibilities for low-level programming, and not to mention about high-performance systems. And I think this was it in terms of history and what it appeared in at least the most important versions. So now that we've gone through this, it's time to switch gears again for a second round of trivia. Some of the questions now are technical. It's the same quiz. So if you haven't scanned it the first time, I did it again. If not, you can simply just continue, and I'll press the next questions once we get to it. The following questions will dive into the Java Quirks technical features and its unique role in tech culture. I try to put something a little bit funny, and I'm curious to see if you'll figure it out that correctly. So, ready again? Let's start. The next question, a bit technical. And this one looks that is actually trying to trick our eyes more than our brain. We are assigning values to 3 variables, A, B, and C. And each of them is using numerical literals with underscores. So A is 1_30, B is 10_20, C is 100_0, and I could have continued like that. The question is, will the expression A equals B and B equals C evaluate to true or to false? Let's see, what do you think? Hope you have your phones ready because I'm going to enable the question. Your time now. Let's see, what do you think? It is correct or not? Okay, both of them are being selected, so some of you consider that those evaluations will result in a true, others not. Less than 50 seconds now to submit your answer. Curious to see what's the final result over here. We have 70% and almost 30% in terms of answers. All right, let's see who is right. So all of you that selected A, meaning true, you are totally right. And because a lot of you selected that is false, let's break it down. So we have A. A is 1_30. This, from a mathematical perspective, is 1,000. Afterwards, we have B, which is 10 and _00. From a mathematical perspective, this is also 1,000. Then we have C, which is 100_0. Once again, yep, this is still the same value. So underscores in numerical letters are just visual aids. They don't change the actual value of the number. They are ignored by the compiler because it's just a visual aid, as mentioned. Behind the scene, it's still the same number for all of those numbers. I could have added something like 1_30_30_, you get the point. Behind the scene, it's still the same because we are simply putting the same value with an underscore. So yes, the right answer is A, true. Let's see how you deal with the second question, because now it's time to separate fact from fiction. And this one, pay attention, that is a multi-select round. So you have to choose all the statements that you think they are correct. And you can submit your answer right now. Out of these options, what do you think the correct ones are? And please select all of them. All of those that you consider they are correct. Not all of them. I don't provide any spoilers. Ah, you can do that. Sorry. You can do it now. I had to press twice this time. So, let's see. A. Java was originally called GreenTalk. Maybe it was, maybe it wasn't. You can write Java code entirely using emojis. Can we use or can't we use emojis in Java? The first Java browser was called WebRunner. Maybe yes, maybe not. Java was once banned from Apple platforms. Was it? And the last, JVM, stands for Java Virtual Machine. So there are 5 answers. Some of them are correct. I'm not going to provide any spoilers. But the time's up. Let's see a bit what you have selected. So almost everyone selected E. And winner voting, at least C and D. A, nobody selected. B, a couple of you. I think the answers are going to surprise you a bit. And I will show you now. You can see them on the phone. You can see them here. Yes, we had, you may argue that we had a question with the original name, and this time it's GreenTalk. I'll explain why. So Java began as a project called Green. This was the initial project, and it was created by Sun Microsystems in 1991. And the term initially named was GreenTalk. And afterwards, it was renamed to Walk. And initially, it actually had the extension of GT from the GreenTalk. So this was the original name. Afterwards, it was changed to Walk after the Walk tree that was outside the Gosling's office, which also was changed because of some trademark issues with the Walk technologies. And the reference source is actually one of James Gosling's interviews. And I was also surprised because if you search on the internet, all the references are only mentioned about Walk. But if you hear his interviews, well, the first name was Grain Talk, so this was correct. I didn't try to trick you, but this I was curious to see how many have read about that part. Afterwards, B mentions that you can write Java code entirely using emojis. This is incorrect. While Unicode allows a wide range of characters in Java identifiers, like variable names, well, emojis are not allowed. As valid starting characters for class, for methods, for variable names, you might hack something, I won't argue that, using escape sequences or comments, but Java syntax rules are strict about this. Java identifiers must start with a letter, the dollar character, the underscore, but not emojis. So I see a couple of you selected this one as well. Afterwards, option C mentions that the first Java browser was called WebRunner. Most of you selected it right, so you are right about this. WebRunner was the original name of the first Java-based web browser, and it was also developed by the team at Sun. It was later renamed to Hot Java, and it was the first browser to support Java applets. Afterwards, the next option, Java was once banned from Apple platforms. Well, it was never officially banned, so this is why it wasn't correct, but also a lot of you selected it. Around 2010, Apple deprecated Java support for macOS, shifting responsibility to Oracle, but they weren't banned completely. So it continued to work. Java has always been installable on the macOS, so it wasn't true. And the last one, I think we don't have to discuss about it. Everyone selected it, so JVM, yes, stands for Java Virtual Machine. All right. I have a couple more with multi-select, but let's relax a bit with a technical one. And here, let's dive into a Java concept that might trick a bit, the string interning. So in this code snippet, we got two strings. We have S1, which is a string literal, and S2, which is created with a new keyword, meaning that it's a new object in memory, even though the content is the same. But then, what do? We do something interesting. We call s2.intern method, and we assign that result back to S2. So what does intern actually do? If we were to run this code now, what will we get? A true, false, compilation error, or a runtime exception? And I'll make sure you can submit your answers now. And let's see, what do you think? What does that intern method do? Equally percentage for all of the options so far. Let's see if one of them will stand a bit. Still 15 seconds left for you to submit your answers. So you have two different objects, same content. All right. Most of you selected true, but all the others also have a quite high percentage. So let's see. And at least those of you that selected true, you're right. Let's see what that intern method does. So it returns the canonical representation for the string object. So it tells the JVM to check the string pool. And a special memory, which is a special memory area for storing string literals, we know about it, and it returns the canonical representation. So in this case, when we call that s2.intern method, it returns the reference from that string pool, which is the same as S1. So when we compare S1 with S2, this time we evaluate to true. And this is a great reminder, because in Java, if we were to use the equality operator without calling that intern method, it wouldn't have resulted in true. It would have resulted in false, because there are two different objects, two different references. All right. Let's see another one, a funny one with string concatenation. There are 30 years of Java. So let's see what is the output of this single line of code. It's a concatenation puzzle, if I can name it like that. It may look simple, but the order of the operation matters, because it can break your answer. So we have a single print line statement over there, mixing numbers and strings. We have 10 plus 20 plus Java plus 10 plus 20. Let's see what do you think the right answer is. And you can select now. We have those 4 options: 30 Java 30, Java 1020, 30 Java 1020, or 1020 Java 1020. Let's see. Less than 20 seconds now. The votes are still coming in, but we are in between C and D, I think. Time's almost up, and that's it. Let's see. So, from your point of view, at least most of you selected answer C, and on the second place is option D. So we are in between either 30 Java 1020 or 1020 Java 1020. And the winner is C. So most of you answered correctly. Let's explain now why. So Java evaluates expressions from left to right. We know this. So far, so good. And the plus operator works in both situations, for integers and for strings. When we have a string right after the plus operator, before the plus operator, we have a string. Everything that is following afterwards is converted to a string. Let's take them from left to right. First, we have 10 plus 20. No strings yet, so this results in 30. It's just handling 2 numbers. Then we have 30 plus Java. Java is a string. So I mentioned that what follows afterwards is converted to a string. So now we get 30 Java. Then finally, we have 30 Java plus, and we have 10 first, which it becomes a string. So we have 30 Java 10. And the last one follows the same rules. We have 30 Java 10 plus 20 converted to a string, and we end up with 30 Java 1020. So it was a sneaky one, I have to admit, but it matters because we need to understand the operator precedence rules. All right, next question. I have a few more. Now, let's test your awareness of what is new or not quite ready. You need to be careful of the wording in my question. Because I'm asking about which are not yet stable or not yet available as features in Java 24. So let's see how up to date are you. And here you're looking at a mix of real and proposed features, but only some of them are officially stable or available as of Java 24 today. So don't select those that you think they are correct. Select those that you know that they are not stable or available in Java 24. And once again, it's a multi-choice. And you have more time to select. So, read carefully and make your choice. You can submit now. We have pattern matching for record types, smart pointers, value objects, primitive classes, foreign function and memory API, and virtual threads. Less than 20 seconds. All of them were selected. All right, time's up. And let's see if the answers will surprise us or not. If I were to select a winner from those options, those 6 options, I think smart pointers might be one of the answers because most of you selected it. It's the only common one. Let's see. You can see them on the phone. You can see them on the screen. So pattern matching for record types. Let's name them one by one. Starting with pattern matching for record types. They are available in Java 24. So if you selected this, means that you haven't read carefully the question. It was about which one were not stable or not available. So we do have a stable feature in Java 24, allowing matching components of records in conditions. Then we have smart pointers. Well, they are not available in Java at all, not to mention Java 24. It's not a Java concept. Smart pointers belong to C++, and they help with manual memory control. Java uses automatic garbage collection. It doesn't support pointer semantics, so this was one of the answers that should have been selected. Afterwards, we have value objects. Well, they are not stable yet. They are part of the Valhalla project. The value objects aim to create memory efficient, identify less types, but they are still in development, so not yet in the Java 24 release. Next, we have the primitive classes. Also, the same, it follows the same as the value objects. They are not stable yet. They are also part of the Valhalla project. They enable classes that behave like primitives, so no identity, better performance, but it's still it's still incubating. They are not officially in the Java 24 language. Afterwards, we had foreign function and memory API. They are in preview mode at this moment. They are part of the project Panama. They allow calling native libraries, but it's still in preview as of Java 24. Then we have virtual threads. They are also available. They are part also of the project Loom. We discussed earlier about them, and they became stable in Java 21. So they've been in the API for some time already. All right, let's see, just a few more. Let's test now your deeper knowledge on Java's language and the JVM, especially how some of the internals and modern features behave as of Java 24 again. So this time, I'm interested in see the statements that are true related to Java 24, or all the versions up to Java 24. Some of these might sound familiar, but don't be tricked by legacy behaviors or myths. So let's see which one of these you consider they are correct, and you can submit your answer now. Just a few more seconds left. All right, and these are the answers. So let's take them once again, one by one. The first one was correct, and I see most of you selected, so totally right. All right, I was looking at the answers that you have submitted. So, JVMs supports ahead of time compilation to enhance startup times. That is correct. Unsafe class allows for direct memory access and is still fully supported in Java 24. This is false. And that's because it has actually been deprecated for removal in Java 23. So this is going to be, it is deprecated, so definitely not something that we want to continue using it. And in Java 24, using these methods will issue a runtime warning, encouraging developers to migrate to something like var handler, for example. Afterwards, we have C, which mentions Java supports multiple inheritance through interfaces only. This is correct. Java does not support multiple inheritance for classes. However, a class can implement multiple interfaces. This is the basic. Then we had lambda expressions can be used with static methods. This is also correct. They can be used with static methods, provided the static method matching the functional interface abstract that matches the method signature. And the last one, var is type safe and can be reassigned to different type after initialization. Well, it is used for local variable type inference, but once a variable is being assigned a type, it cannot be reassigned to a variable of a different type. So this ensures type safely and prevents runtime type errors. All right. And I think this will be the last question because time's almost up. And this time it's time to separate Java fact from Java fiction. And yes, I'm throwing a bit of pop culture over here. which one of the following statements do you think they are correct? And you can submit your answer. Let's see. If you've seen Iron Man in 2008, was Tony Stark used a Java-based interface to control his Iron Man suits? Or maybe his original first logo was an image of JavaScript? Or the famous Hello World program was inspired by the scene in Star Wars, based on the R2-D2 first speech? Or Minecraft was originally developed in Java and later a separate C++-based version known as Bedrock Edition was created? And let's see. Last question. And it's time to reveal. And the only correct answer was D. Regarding the Iron Man part, there are no valid references. It might be, but it might not be. It is more of a futuristic technology rather than Java. So the only answer, the correct answer here was D. And indeed, Minecraft was originally developed in Java and later on in C++. And I'll also reveal the final leadership, because I did mention bragging rights are on the line. So congratulations to everyone that participated. And I also wanted to thank you for your participation. I hope you had some fun. Time's up, so I think questions, if you want, we can take them afterwards. I'm still around here. Once again, thank you for attending, and have a great day ahead.